Actually have a go at applying this, and have a go at sketching a few different polynomials. Now we're going to pull together all the stuff that we've looked at so far. So let's have a look at this first example. Okay, so p of x is equal to x minus 1 all squared times x minus 2 times, and that's it. Okay, now the first thing I'm going to do is I'm going to look at the stuff that we looked at the beginning. First, we're going to look at what the leading coefficient is. Now, let's have a look here. The leading coefficient, I only need to worry about if it's positive or negative. Now, you could expand out this whole thing to find what the leading coefficient is. That's fine. You could totally do that. But because I'm multiplying them together, all I need to do is look at if there's a number at the front that I'm multiplying them with. Here, I don't have a number, which means I'm multiplying it by 1. Now, 1 is a positive number. So I'm going to write leading coefficient is equal to 1, which is greater than 0. What this tells me, and you don't need to write this down whenever you're doing graphing, but what this tells me is that when x goes to infinity, what does this tell me? When x goes to infinity, my polynomial is also going to go to where? It's going to go to infinity. So it's going to end in the top right quadrant on my Cartesian plane. So let me just draw this as I go. So I'm going to maybe over here. X, y. So it's going to actually end up going towards that direction. That's what this first dot point tells me. First part tells me. Okay, the second part is then I check the degree of the polynomial. Now here, the degree is just the highest power of x. Now, if you remember earlier when we looked at polynomials, when we looked at polynomial multiplication, the degree of p of x times q of x is equal to the degree of p of x plus the degree of q of x. Now you might be wondering, why am I telling you this? Well, it's actually quite helpful for us if we're trying to find the degree of a polynomial when it's in this factorized form. So what we notice is that, well, let's have a look at both of my factors. If I look at this first factor here, what degree is going to be, what is the degree of this going to end up being? Well, because it's a square, the degree is going to end up being 2. So actually I forgot to write degree p of x. The degree of that is going to be 2. Let's have a look at the second bracket. What's the degree of this one going to be? Well, it's just degree 1 because it's a simple, it's an x minus 2. The high power of x here is 1. So I'm going to use this fact here. Because I'm multiplying these two factors together, all I need to do, if I want to find the degree of this final polynomial, all I need to do is just add these degrees together. So the final degree is actually just going to be 3 because I do 2 plus 1. All right, here 2 plus 1 is equal to 3. Now this is 3 odd or even? It's odd. So what this tells me is that on the other side, when x goes to negative infinity, it's not going to go in the same direction as when x went to infinity. So it's going to go the other direction. So as x goes to negative infinity, p of x goes to negative infinity. So using that information, I've got this here. Okay. The final step that I'm going to do is I'm going to look at the zeros and look at that multiplicity. So where are my zeros for this polynomial? Well, when we were reading off zeros for our quadratics, we just solved each of the factors separately. So my zeros are x is equal to 1 and x is equal to 2. Now when x is equal to 1, what's the multiplicity here? So x is equal to 1 was this first bracket here. Well, this has multiplicity 2. So what that means is that when x is equal to 1, and I'm actually going to move my y-axis a little bit just so I can make this look a little bit better. When x is equal to 1, so when x is equal to 1, what's going to happen is, well, there's nothing going in between, so it's going to actually have this kind of turning point shape. Okay, cool. So when x is equal to 1, we've got that. X is equal to 2 has a multiplicity of, what's the multiplicity of x is equal to 2? It's just 1. So that means when x is equal to 2, it's just going to cross the x-axis. Now the reason I drew it in these directions, so for example, the reason why I didn't draw this in this direction was because, well, have a look at the other information I've got. I've started from the left, and because I've ended up, so if you have a look down here, my polynomial, when it starts from the left, it's going down in that direction. There's nothing else changing its direction. So I know that it has to start and match with the same direction as So for my 0 at x equals 1, it needs to match that direction. So that's why I'm drawing it matching in that direction. And that's why for the x equals 2, I need to match it and draw it cutting in that direction. Okay, so if I was to draw my polynomial, it looks something like this. I know it ends up in here, but I'm just going to draw it so it kind of uses all that information. Here we go. Ooh, okay. So this polynomial here, and you can draw it a little bit better than I do have, you can probably curve out that 0 at 1. But let's just check that we have all that information. The leading coefficient means that when it goes to infinity, our graph, when x goes to infinity, p of x also goes to infinity. That's what we have over here. So here, x goes to infinity, p of x goes to infinity. On the left-hand side, we've got because it's odd degree, when p of x goes to, when x goes to negative infinity, or x approaches negative infinity, p of x goes in the opposite direction. So p of x goes to negative infinity. That's what we have over here. Now here, when we did our zeros, our 0 at 1 had multiplicity 2, so we had that turning point. And our 0 at 2 had multiplicity 1. It cut through the x-axis, just like it did when we had these shapes here. So that's how we draw a polynomial using all of this information that we have here. So if you need to go through this again, feel free to stop it and pause it and go through any part that's a little bit slower. And maybe if I need to explain something, feel free to ask a question.